Alright, so we continue with this confidence interval. So the general formula for confidence interval will be equal to uh, the mean plus minus. This one is confidence intervals. Sorry. I remove first this part. Remove first. Okay. So the confidence limit, right? We will have a formula equal to mean plus minus z, okay, sigma over square root n. Okay, so the behind part right here, this one, you may use square root of sigma square over n also can, right? So the z is the z that just now depends on the how many percent of the confidence interval, right? So this is a confidence limit, right? So if you expand this confidence limit, okay, you will have a confidence interval, okay, in the bracket, okay. So the lower boundaries will be the mean minus z sigma over square root n, okay, and the upper limit will be plus z sigma over square root n. Okay, this is the confidence interval. Okay, so as you know that the midpoint, okay, will be always equal to the mean. Okay, if you proceed, if you want to calculate the width of this interval, how the width of this interval is how much, okay, so the width will be equal to 2 times the z, okay, sigma over square root n, right? So this is the width, okay. Another way you may use the upper limit, okay, minus the lower limit, okay, so you will get this the width also, but make sure that you use the exact value, okay. If you can't use exact value, please use this formula to find the answer, okay. So this is for the explanation of the confidence interval, right? From this part you will not have any the confidence interval formula you have to memorize, no choice, because did not provide in the formula booklet, right? It's not in the formula booklet, right? Okay, now we proceed to example 3, see how to use this for the example 3, okay. Example 3, okay, the mass of okay, the mass of I forgot to go to the case 1. Okay, so for case 1, right, case 1 before example 3. Okay, for case 1, the distribution is given, is normal distributed, sigma is given, you know the sigma or sigma square, the sample size can be any size. So if the question want you to calculate the confidence interval, you can direct use the formula just now and calculate, right, but you need to confirm the z value before you start to use the formula, okay. So for case 1, we will use example 3 to see how to calculate the values. Okay, example 3, the mass of vitamin E in a capsule manufactured by a certain company is normally distributed with a standard deviation of 0.042. The mean mass of vitamin E in a random sample of 5 capsules was 5.12. Okay. Okay. Question 1. Calculate the 95% of confidence interval for the population mean mass of vitamin E per capsule. Okay. Okay. part 1, example 3. Okay, so you need to form the distribution first, right? So given that sigma is equal to 0, confidence interval, so normally we will start from 95% confidence limit first. Okay, so for 95%, if you refer to the technique just now, okay, this is equal to z square root n, right? The mean is given or not? Oh, mean is 5.12. Okay, and plus minus z. Okay, 95 confidence intervals. Okay, so means you need to find the z value, pz smaller than z is equal to 0.975. So you will get the z value equal to 1.96, 1.96, 1.96, sigma 0.042, okay, over square root 5. Okay, so this is the confidence limit. Okay, so if you want to calculate the confidence interval, you should simplify the equation. Okay, so when you simplify, you will get 5.12 plus minus 0.038, something like that. So try to keep 4 to 5 decimal. Okay, and by calculating this, your confidence interval will be equal to, okay, the first one will be 5.12 minus 0.0368. You will get 5.08. Okay, 3SF. And the upper part will be 5.12 plus 0.0368. You will get 5.16. Okay, so you will have this confidence interval. Okay, right? So actually very simple. Okay, so important is you know how to find the z. Okay, and part 2, calculate the width of confidence interval. So for the width, okay, the width will be equal to 2 times 1.96, okay, 0.042 over square root 5, right? So this one you can direct calculate, should be equal to 2 times 0.0, just now 038, right? So you will get the interval, the width is equal to 0.0736, alright? So this width will be the distance between the lower boundaries to the upper boundaries, right? So the confidence intervals, the width of confidence interval. Part 2. Part 3. 60 random sample of 5 capsules are taken at a 95% confidence interval is calculated for each sample. How many of these intervals would you expect not include the mean? Right? So as I mentioned before, 95% definitely will include the mean. Alright, the center part, because of the mean at the center. So the part that not include mean will be, so 95% include mean the remaining one not include mean, right? So means 0.05, right? 5% not include mean. So you will use the 0.05 multiply 60, right? Total 60, right? So it's equal to 3. So your answer is 3. You will expect that 3 intervals did not include mean, right? 3 intervals, right? So the question is like that. Question 3. Okay, can we proceed to question 4? Question 4. Okay, for question 4, the mass of sweet produced by a machine are normally distributed with a mean milligrams and standard deviation 1.0 grams. A random sample of 65 sweet product by the machine has a mean mass of 29.6 gram. Find the 99% confidence interval for mu. Right. So the mean already given. Okay. So now for 99% confidence interval, okay, now let us find the Z first. So here is 99% center. So the outer will be 0.005, 1%, 0.005, 1% divided by 2. Okay, so the Z that you want to find, Pz smaller than Z, this one, right, is equal to 0.995. Okay, 0.995. If you look at the table, 0.995, what you get? 0.995. The critical value table don't have. Yeah, got 0.995 from the critical value tables is Z equal to 2.576. Do you find that? Try to find out from the critical value table, the below one. Okay, 2.576. Once you have 2.576, you can calculate the confidence limit first. Confidence limit is equal to 29.6. Okay, plus minus the Z is 2.576. Just now we found. Okay, and sigma that given is 1 over the sample size 65. Right. So by simplify, you should get 29.6 plus minus 0.3195. So the confidence, okay, the confidence interval will be equal to, okay, the lower part 29.6 minus 0.3195 will be 29.3. Okay, the upper one will be plus, will be 29.9. Okay, so this is the confidence interval for this question 1, part 1. Right. Okay, part 2. The manufacturer claims that the machine produces a sweet of a mean mass of 30 grams. Okay, claims that 30 grams. Use the confidence interval to found in the part 1 to draw a conclusion about the grams. So you can see that, okay, the confidence interval that you found from the sample is equal to 29.3 and 29.9. But the question say they claims that the mean of the production is 30 gram. So what you can say about that? So you can say that part 2, the confidence interval does not contain 30. Right, so mean what? Okay, so mean what? So means the manufacturer claim is not supported lah. So if their claim is correct, okay, can accept the claims, the 30 must be in the interval. Let's see, this interval did not contain 30, so mean the claims is not supported lah, right? It's not supported. Okay. Okay, so you can say the claims is not, the manufacturer claim is not supported, right? So part 2. Part 3. Okay, another random sample of 65 sweet produced by the machine is taken. Another testing. This sample give a 99% confidence interval that leads to a different conclusion found in part 2. Assuming that the values of mu does not change, right? Explain how this can be possible. Okay, so now that you have a new sample, okay, and now the result is acceptable. So what you can say about this? Okay, so for part 3, you can say that as the claim is supported, the confidence interval construct from the second sample must have content 30, right? So confidence interval can change according to the value of the sample mean, right? So this is the things, right? So I repeat again, as the